This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The last part of Bernouilli trials is for higher level only. Involves calculating the probability that the kth success occurs on the nth Bernouilli trial. To see how this is done, we will work through a question. The question states that an experiment consists of throwing a fair six-sided die, and if the die lands on a 5 or 6 is considered a success, else it is considered a fail. Firstly, we need to find the probability of winning on one throw of the die. This is a normal probability question. The number of successful outcomes is 2, as we can throw either a 5 or a 6 and it's considered a success. Total number of outcomes is 6, which simplifies to a third. So the probability of winning on one throw of the die is a third. The next question asks us, what is the probability there are 2 wins when the experiment is repeated 5 times? This is a binomial experiment question, and we need to use our binomial experiment formula for this. In this case, n, the number of trials is 5, as we repeated the experiment 5 times. X, the number of successful outcomes is 2, and we take that from the question. P, the probability of a successful outcome. We worked out this probability in the first question, so this is equal to a third. Q is equal to 1 minus P, so Q in this instance is equal to 2/3. So now all we have to do is fill into the formula. The probability X is 2 is equal to n, 5, choose 2, multiplied by a third raised to the power of x, which is 2, multiplied by q, which is 2/3, raised to the power n minus x. N minus x in this case is 3. 5 choose 2 is equal to 10. Third raised to the power of a half is equal to a ninth. And 2/3 cubed is equal to 8/27. And if we multiply this together, we get a value of 80/243. I will tidy up the slide before proceeding. The last question follows from question 2. The last question asks us, what is the probability that the third win is on the 6th throw of the die? What it's saying is the probability that there's 3 wins and the third win is on the 6th throw. If we think about this, it doesn't matter when the first 2 wins occurred. By this I mean you could win on throw 1 and throw 2, or throw 1 and throw 4. The first part of this question is really therefore the probability of 2 wins in first 5 throws. The last part of this question is that the third win is on the 6th throw of the die. This event is independent from the probability of 2 wins in 5 throws. Therefore, we can multiply the probability of 2 wins in 5 throws by the probability of winning, where this probability of winning represents our third win. This is equal to 80/243, which we worked out from part 2, multiplied by a third, which we worked out from part 1. And this is then equal to 80/729. That concludes our discussion on Bernouilli trials.